Hello viewers, I am Kausalya. Today we are going to solve problem number 10 under the topic Nyquist plot. It will be better if you go through the procedure of how to solve a problem using Nyquist criteria. I will give the link in the description. The problem is sketch the Nyquist plot for a system having transfer function. In addition, comment on the closed loop stability. So, the main difference between this problem and the previously solved problems are, here you see we are having a term with a negative sign. In the previous solved problems, we will be having both poles and zeros or only poles, but all are with a positive sign, right? So, here this is the key difference. So, whenever you are having a problem like this, that is poles with a negative sign, then the procedure to be followed varies little bit, right? So let us solve the problem. First is step number 1. It is finding the number of poles which are lying on the right hand side of S plane. So here denominator terms are known as poles and numerator terms are known as zeros. So now we are going to find all the poles and zeros. So here, yes, S minus 2, we have to equate these two terms to 0. So when you equate it to 0, the value of S is 0 and here the value of S is plus 2. When you move this minus 2 to the right hand side, that becomes plus here, right? And the value of 0 is S plus 4. So S is equal to minus 4. Now we are going to mark these poles and zeros on the S plane. This is our S plane, right? And here we are having 0 and plus 2. So 0 and plus 2 are marked. And the next thing is minus 4. So this is a 0. So it is marked like this, like a small circle, right? So number of poles lying on the right half of S plane is, this is our right half of S plane. We are having one pole here. So therefore it is equal to 1, right? Then regarding step 2, whenever you are having a pole on the right hand side, the number of encirclement formula gets little bit modified, that is n is given by z minus p. Z is number of zeros lying on the right hand side of S plane and p is number of poles lying on the right hand side of the S plane, right? So no zeros are lying on the right hand side, so it is 0, and poles lying on the right hand side, just now we have seen it is 1. So 0 minus 1 gives you minus 1. So this minus 1, what it indicates? The plot should encircle this minus 1 plus 0j point once, okay, one time in clockwise direction. This negative sign indicates the encirclement should be done in clockwise, right? Step 3 is drawing a rough Nyquist plot. Again, look back at the problem here. So in this problem, we are having a pole at origin, right? So accordingly, we have to draw the Nyquist plot. So this is our rough Nyquist plot, right? Since we are having a pole at origin, our plot should not cover those poles. So here we should draw a small semicircle like this, right? And again, right hand side it is 0 degrees. When you move in clockwise, the angles are negative, minus 90, minus 180 and minus 270. When you move in anti-clockwise, the angles are positive, so plus 90, plus 180 and plus 270 degrees, right? And in this typical Nyquist plot, we are having 4 different sections, right? So this is your section 1, this is your section 2 and this is section 3 and this is section 4. So section 1, what is the starting point? It is plus j infinity and it ends at plus j0. And second section, it starts at plus j0 and ends at minus j0. And third section, it starts at minus j0 and ends at minus j infinity, right? And step 4 is, we are going to write expression for magnitude and phase angle. So in the given problem, just replace s by j omega, right? We are having expression like this. An expression for magnitude is nothing but we have to square the elements as well as we have to take the square root. So here omega square plus 4 square, and here omega again, when you square this and when you take square root, again these two cancels each other and simply we will be having omega. And finally here omega square plus minus 2 the whole square gives you omega square plus 4, right? So magnitude expression is this. And next we are going to write expression for phase angle. So in writing expression for phase angle, a key thing to be noted is, you see here we are having j omega minus 2. I can write this one as minus 2 plus j omega. Is it right? Here j omega minus 2, and here I am writing it as the same thing, minus 2 first and plus j omega later. Okay, both are same. Now we are going to plot this point on a S-plane. So minus 2 plus j omega, right? So where comes minus 2? It comes on the negative real axis. So here lies minus 2 and plus j omega, it will be somewhere here, right? So here I am locating that point, right? Where is this point get located? It is located in the second quadrant, right? This is our first quadrant and this is our second quadrant. So whenever we are having a point on the second quadrant, our phase angle expression gets bit modified. You see, I'll explain. As usual, we will start to write. So here, when you write it, the phase expression, it becomes tan inverse of omega by 4, right? And omega contributes 90 degree. When I move this omega to the numerator, it becomes minus 90 degree. And here I am having a pole in the second quadrant. So here I have to write that one as 180 minus tan inverse of omega by 2, right? And since this is a denominator term, I am moving this to the numerator. So here I have included a minus. So what happens when you move this minus inside, here we will be having expression like this. Minus 180 plus tan inverse of omega by 2, right? So this is the expression for the phase angle, right? Now we are going to do section wise analysis. First we will start with section 1. Here the starting point is plus j infinity and ending is plus j 0, right? So plus infinity and plus 0, just substitute these values here. So this is our expression for magnitude, right? When you substitute infinity, anything divided by infinity is 0. So here write 0. And when you substitute the value of omega as infinity here in this expression, right? What happens? You see, this is our expression and here I had substituted infinity values. So 90 minus 270 plus 90, when you solve this, we will be having minus 90 degree as answer. So here it is minus 90 degrees, right? And again, when you substitute omega value as 0, so anything divided by 0, it is infinity. So here it is infinity, and again when you substitute the value of omega as 0, here in the phase angle expression what happens? You see, this is our expression, right? So this tan inverse of 0 is 0 and tan inverse of 0 is again 0. So here we will be having minus 90 minus 180. Right, so minus 90 minus 180 is nothing but minus 270 degrees. So here the answer is minus 270. And as usual step, we have to subtract these two. So minus 270 minus of minus 90, the answer is minus 180 degree. So we have to draw the Nyquist plot in clockwise direction and we have to rotate it through 180 degrees. Right. Now we are moving to section 2. So in section 2, the starting point is plus j 0 and the ending point is minus j 0. So here starting omega is plus 0 and ending point omega is minus 0. Again we are going to substitute these two values here. So when you consider the magnitude expression, anything divided by 0 is infinity. So since here we are having both the terms are zeros, right? One is plus and another one is minus. So the magnitude is infinity. And now we are going to substitute omega as plus 0. So when you substitute omega as plus 0, the answer is minus 270 degrees. Just now we had seen, right? So write the values here. And next thing, when you substitute omega as minus 0, here the thing is, you see, in the phase angle expression, anyhow when you substitute 0, this term reduces to 0 and this term reduces to 0, and remaining things will be minus 90 minus 180. Since our Nyquist plot crosses origin over there, this minus 90 degree we have to insert another minus sign, that is minus of minus 90, it is plus 90 degrees, right? So here that is the thing which is done. This term reduces to 0 and this term reduces to 0. Here we are having minus 90 already. Since our plot crosses origin, here we are including another minus sign. So minus of minus 90 had become plus 90 here. Right. So plus 90 minus 180 gives you minus 90 degrees. So here it is minus 90 degree. Again we have to subtract. So minus 90 minus of minus 270 becomes plus 270. So the answer is plus 180 degree. So the plus sign indicates the direction should be in anti-clockwise. Right. And section 3, it is a mirror image of section 1. And section 4, it is not needed. And step 5 is rationalizing. So rationalizing is nothing but taking complex conjugate. Right. So here this is the given problem. So here we are taking complex conjugate of the denominator terms. So plus j omega multiplied by minus j omega and minus 2 plus j omega. So here minus 2 minus j omega. We are multiplying and dividing, okay, at the same time. So the next step is we are just multiplying the numerator terms as well as the denominator terms. So here when you look at the denominator term, you see j omega into minus j omega, it becomes omega square. And here this is when you consider these two factors, one is of the form a plus b and another one is a minus b. So the formula is a square minus b square. So minus 2 the whole square becomes 4. And this j omega whole square, and again here we are having this minus we are having, right? So that becomes plus here. So 4 plus omega square. And the numerator terms just we have to multiply. That's it. Right. So after multiplying, here we are separating the real and imaginary terms. So after separating real and imaginary terms, the next step is we have to equate the imaginary term to 0. So when you equate this imaginary term, here our imaginary term is 10 is common for both, right? So 10 into this term. This is our imaginary part. So equate those terms to 0. So here when you move this term to the right hand side, 0 multiplied by anything is again 0. So finally we will be having 8 omega minus omega cube equal to 0. So once you solve this, here we are having the value of omega square as 8, or omega is equal to square root of 8. Now we are going to substitute the omega square value in real term. So here the real term is 10 into minus 6 omega square divided by omega square into 4 plus omega square. So here just substitute the values. So once you substitute the value, here finally we are getting the value of q as minus 5. Right. So q is nothing but intersection of Nyquist plot on the negative real axis. Right. Now finally we are going to draw our Nyquist plot. So to draw the Nyquist plot, we should have the final answer of section 1 and section 2 analysis. So this is for section 1 and this is for section 2. Right. So here the scale you have to mark like this again. So here 0 degree, when you move in clockwise the angles are negative, minus 90, minus 180, minus 270. When you move in anti-clockwise the angles are positive, plus 90, plus 180 and plus 270 degrees. Right. So this is our section 1 values. So it starts at 0 minus 90 degree. So where is your minus 90 degree line? It is here. Right. So it starts at 0 and here it moves in clockwise direction 180 degrees. Right. So clockwise it is like this, right? So it moves in clockwise direction. Where it is getting ended, it ends at minus 270 degree line with the value infinity. So this is our minus 270 degree line. So it starts here, it has to cover two quadrants. So first quadrant, second quadrant, and it ends at minus 270 degree line, right? So our section 1, we have drawn the plot for section 1. And next, we are moving to section 2. These are the values of section 2. So it starts at infinity minus 270 degree, right? So this is minus 270 degree and here is the infinity. And we have to rotate 180 degree anti-clockwise. So this is anti-clockwise, right? So 180 degree we have to cover two quadrants. So first quadrant and second quadrant. Where it has to be entered? It has to be entered at minus 90 degree line infinity. So this is my minus 90 degree line and let this point be infinity, right? So this is our Nyquist plot for section 2. And as we had seen, section 3 is nothing but it is mirror image of section 1. So this is my section 1. So here I had drawn the mirror image for section 1. So this is our section 3. Right? And for section 4 it is not needed. So finally this is our Nyquist plot. Now we have to tell whether the system is stable or unstable. Right? So what is the value of Q? Q is nothing but intersection point on the negative real axis. So the value is minus 5. Right. Now just tell me, here it is minus 5. So minus 1 will be encircled, right? Because minus 1 will be lying in this area. For example, this is 0. So this is minus 1, minus 2, minus 3, minus 4 and minus 5. So minus 1 will be lying in this area. In other words, technically saying minus 1 plus 0j point is encircled, right? So now to know the number of encirclements, just draw a line from the minus 1 plus 0j point, right? You just draw a line like this. After drawing the line, you just count the number of lines that crosses our this drawn dotted line. So to this line, you see where I am having this curve and as well as this curve, right? So we are totally having these three lines, 1, 2 and 3. So just draw the same lines here with respect to arrow directions. So here it is in anti-clockwise. So sorry, here it is in clockwise and here this is also in clockwise. So 2 clockwise and this is in anti-clockwise. So 1 in anti-clockwise. So arrowheads we are having how many? Here we are totally 2 in clockwise direction, right? So 2 in clockwise means here it is minus 2, right? And 1 in anti-clockwise it is plus 1. So here these two should be represented as minus 2 and this should be represented as plus 1. So minus 2 plus 1 gives you minus 1. So minus 1 is nothing but the total number of encirclements around the point minus 1 plus 0j is in clockwise direction. Okay. Now just compare this with the step number 2. So this is our step number 2. Here also the value of n is minus 1. Right. So here also from the Nyquist plot we are having the value of n as minus 1 and this matches with step number 2. Right. So therefore the closed loop system is said to be stable. Right. Hope you people understand the problem. If you have any doubt, let me know in the comment section. Thank you.